All right, we're going to go ahead and work with the natural base e. So an irrational number is symbolized by the letter e. E is approximately 2.71. So here is that irrational number in expanded form. Your textbook calls it approximately 2.72. So either one is fine. Your calculator button is e to the x power. Here are the two ways that you can use the calculator as a scientific or a graphing calculator. Below is comparing an exponential of base 2. So y equals 2 to the x power to our exponential y equals e to the x, or y equals approximately 2.72 to the x. So the difference is it's a larger base, it's going to increase faster. So we're going to go ahead and graph this function. Now I have taught you to graph the parent function and then do the transformation. So here is our parent. So we evaluate the function for e to the x. We're going to just choose three numbers today, -1, 0, and 1. E to the -1 power is 1 over e, or 1 over 2.72. E to the 0 power, anything raised to the 0 power is 1. And then e to the first power is approximately 2.72. So we're going to graph that parent function. All right, so first order pair, -1, and then 1 and 2. So it's about 1/3. Small as I can go there. And then over 0, up 1, over 1, almost up to about 3. So here is our exponential function of base e. The domain of that parent function is the same as a base 2, a base 3. It's going to have that all real numbers. It also has that horizontal asymptote at y equals 0, y-intercept of 0, 1, range of values above that blue line. All right, now we're going to go ahead and do the child. So we have to figure out what is happening when you do a +1 up in the power. So we're going to go up in our notes. +1 in our power. What happens to our graph? It moves to the left 1 unit. So each of these ordered pairs are going to move left 1 unit. So if this is my first ordered pair, it's going to shift 1 unit to the left. If this is my ordered pair, it'll shift 1 unit left. And you would continue moving those ordered pairs left. Your other way to do this, and we've talked about this in a previous video, is to just evaluate the function. So I'm going to write this in purple. Y equals e to the x plus 1. And we'll use those same three numbers, -1, 0, and 1. So we're substituting -1 into the purple function. So e to the -1 plus 1, e to the 0 plus 1, e to the 1 plus 1. So this represents about 1/3 plus 1. This is 1 plus 1, which is 2. And this is about 2.72 plus 1, which is 3.72. So that's the other way to do it, is to get your ordered pairs by evaluating the function. So the domain of this purple function is all real numbers. Our range, our horizontal asymptote has not changed, so it's still at y equals 0. So then our range of values is everything above that horizontal asymptote. Notice our y-intercept has moved to 2. This is our y-intercept. So you can choose if you want to graph the function using the transformation rules or to just evaluate the function like I did in this chart.